Hi, we are back with the second kind of chunk of topics for this class. So you should have the new packet of notes printed or available to look at. I'm calling it chapters 4 through 6, but you're going to notice that there's a little bit there's like a section from chapter 10 in here, and not all the sections from chapter 5 and 6 are in here. So it was just kind of easier for me to call it chapter 4 through 6, but yeah, whatever topics we cover in this notes packet, that's what will be on test number 2. So these modules that we're using right now, these are all for test number 2. I feel like I had something else important to say, but I can't remember it. So I'll probably think of it while we are working on fractions. So let's go ahead and get started. Oops, did it again. Forgot to share my screen. Voila. All right, so here we are with 4.1. That is, all these toolbars are on my screen. I can't read. There we go. 4.1, Introduction to Fractions, Improper Fractions, and Mixed Numbers. Oh, and look at that. I remember what I was going to say. So what I was going to say is these sections, like 4.1 or whatever numbers they are, the reason they're labeled this way is because that is the section they are associated with in the OpenStax book. So I didn't really talk about the OpenStax book in the last couple of videos. I don't know why, I just forgot. But if you go to OpenStax, the webpage, just Google OpenStax with an X, and look for the pre-algebra text. It's also mentioned in the syllabus. You can either look at the textbook online for free or download the PDF of the textbook. For any sections you feel like you need more information on, that's a great place if you want to read and see more examples. So that's why the sections are numbered the way they are. They correspond with that textbook. Also, if you look at the module overview at the bottom of every single module, I've posted extra videos. These are not videos of me. They're videos that I found online, but they're very short and they're based on very specific topics. So if there's ever a topic that you need more information on, that's another great place to go. All right, now I am ready to start. So we're talking about fractions. I know a lot of people in the world are generally uncomfortable with fractions. And so I just wanted to start at the beginning. And so number 1, which number represents the numerator? So the numerator is on top. So this number right here, the 3, is our numerator. Number 2, which number represents the denominator? And the denominator is the number on the bottom. So that would be the number 4 in this example. Okay, again, I did not really do too much in the homework with regards to models, but I did want to just talk about it briefly, just to kind of make sure if you do see any explanations or any write-ups about models, I just want to explain what they're talking about. So here we have a giant rectangle, and it is cut into 4 pieces. And so the denominator is always how many pieces our circle, our rectangle, our square is being cut into. And then we see that 3 of them are shaded gray. So 3 out of the 4 pieces are shaded in. So that is modeling the fraction 3/4. Okay, so that's it for the basics. We talked about numerator and denominator, what a picture of a fraction looks like. And now we're just going to be talking about different types of fractions, how to reduce fractions, all that fun stuff. So number 4 says we are going to convert this to an improper fraction. So an improper fraction is bigger number on top than on the bottom. So this 3/4 on example 3 is called a proper fraction, because the number on top, the numerator, is smaller than the denominator. For example, 4, we want to make an improper fraction, so the numerator will be bigger. And the way we do that, I'm going to write it a little bigger over here. We are going to take the denominator and we're going to multiply it by the big number, by 2, the whole number. and then we will add any remaining. So that would be the 1 extra on top. If this was a division problem, 1 would be the remainder. So we're going to add that 1. So we have 5 times 2 is 10, plus 1 more is 11. And speaking of division, we can see how this all relates to division by doing 5 into 11. 5 goes into 11 2 times. Multiply, subtract, and that 1 is our remainder. So this is how you can check. We have our mixed number here, 2 and 1/5. So 11/5 is the answer, but that division there shows us how you can check how we use the remainder. Which leads us right into number 5, converting to a mixed number. So we just did that. We just need to do it again with 22/8. And what we're going to do is we're going to put the top number on the inside and the bottom number on the outside. And I like to relate as many things to like food and other kind of things as I can. So I just think of in and out. And so if you think of in and out, that order in, out, it tells us where these numbers go in the division. So 22 goes on the inside and 8 goes on the outside. All right, then we divide. 8 goes into 22 2 times. Subtract, and we get 6 left over. And so we will have 6 of the 8s left over. Now, those of you that are comfortable with fractions and you've worked with them a lot, you might know how to reduce this 6/8, which is great. We're going to be doing that later. But right now, we're just practicing on writing them as a mixed number. So what you always want to do on the homework is look how the answer should be written. If it says simplify, then you would want to reduce that, which we'll talk about in a little bit. If it says do not simplify, then we'll leave it just like that, 2 and 6/8. Okay, last one in this part, true or false, converting no, that's not it. Converting 5/3 to a mixed number would give 1 and 2/3. Well, they gave us both answers. So you decide how you like to check it. Do you want to take the 1 and 2/3 and change it into an improper fraction? Or, that's what I'm going to do. Or do you want to do the division with the 5/3? The reason I like doing the mixed number into improper is because even though I say think of in and out, I still have to think of in and out like literally every single time because I always forget the order. And here there's no order. You just multiply and then add. You don't have to remember what goes inside and what goes outside. 3 times 1 is 3, plus 2 more is 5. So we get 5/3, and that is a true statement. All right, so come back here. I got a little better about the organization here in the second set of notes, and so I have labeled it. You'll see right here 4.1b, so I don't have to write that in anymore. And that also is a great reminder for me to hit the pause button or the pause card and give you some time to go off and do your homework. So go ahead and do that, and I will be here when you come back. And we're back. So here we have 4.1b, finding equivalent fractions. So finding equivalent fractions, we want to find a fraction with a denominator of 42 that is equivalent to 5/7. So I have 5/7, and I want to get something over 42. Well, we know we can always multiply any number by 1. It's a funny looking 1, but it has a point. We can multiply any number by 1, and it will maintain equality. So what I'm going to do here is I have to figure out, well, I have a 7, and I want it to turn into a 42. So I can multiply that denominator by 6. And in order to make that 1, that blue box there, a 1, I'd have to put a 6 on top as well. So I have 7 times 6 equals 42 on the bottom. And then I have 5 times 6 equals 30 on the top. So the final answer is 30 over 42. So next up, true or false, 1/4 and 4/12 are equivalent fractions. And if you are good at reducing and you're very comfortable with that, maybe you want to reduce the 4/12 and see if that's true. But I'm just going to continue on like we did on the last problem. And I'm going to say 1/4. What would I multiply that by to equal, to have that 12th on the bottom? Well, it has to be the same number on top and bottom. And I know 4 times 3 is 12. So I'm going to multiply this by 3 over 3. So I keep that giant 1. This is really 1/4 times 1. However, we write that 1, having trouble getting my words out, as 3 over 3 because that's what's going to give us the denominator we need. So 4 times 3 is 12. And then on top, 1 times 3 is 3. And it's asking if it's 4. So we're going to say false. 1/4 and 4/12 are not equivalent. We can see from our math over here that 1/4 and 3/12 are equivalent. Okay, finally, find a fraction. This is just like number 1. Find a fraction with a denominator of 30. So I'll set up my 30. That is equivalent to 6 over 15. So 6 over 15. What do I have to multiply the top and bottom by in order to get that 30? So the answer would be 2. 15 times 2 is 30. Therefore, we have to do the same on top. 12 times, gave away the answer. 6 times 2 is 12. So there is our answer. There is our fraction with a denominator of 30 that's equivalent to 6 over 15. Oh, well, that was a quick little section. You know what? I'm going to go on because that was so quick. I'll put a pause after 4.1c. So finally, 4.1c, ordering fractions and mixed numbers. This is going to be focusing on the number line and then less than and greater than signs. So first of all, it says between what two whole numbers would 17 over 9 be found on the number line? So first I want to think about what 17 over 9 is. So I'm going to find out what that is as a mixed number. 17 goes in, 9 goes out, and then I see it goes in 1 time with 8 left over. So if I was to put this on a number line on the left here, so we have enough room for all the problems, I can see I have 1 and 8, 9. So that's bigger than 1, but it's less than 2. So our number would be right about here. And the answer to the question they're looking at between 1 and 2. Okay, next up on the number line again, it says locate and label the following on a number line. So on the homework, you're going to be given a number line and you will just put the dot there with your mouse. You'll just move the dot around. But I want to show you how you could draw that on your own. So I'm just going to make this one number line. And so 1/6 is tiny. So I would take the space between 0 and 1 and I would cut it into 6 pieces. 2, 3, 4, 5, 6. And 1/6 would just be one of those pieces. So right here is 1/6. 4.5 is bigger than 4. This is not necessarily drawn to scale. It's just going to be what fits on my screen. And so 4.5 would be halfway between 4 and 5. So that'd be right here. And from what I recall, I believe the little lines, like on the one, the little lines already written for you. So you would just have to count 1/6. Okay, then we have some opposites. I know there's a lot of topics here at first. It's just because 4.1 is kind of everything to catch everyone up and make sure some of you are going to breeze right breeze right through this and you remember everything about fractions. Some of you are just gonna, pick and choose which sections you need more help in. So that's what 4.1 is all about. It's about having all the topics there so everyone can see what they need help in. All right, so number 3, we talked about this in the somewhere in the last chapters, 2 or 3. And it says, what is the opposite or negative fraction of 5/3? And it's not really about the opposite in this problem. You know what opposite means. It's about negative sign placement. And so I'll do this one on the left again, just so we have room for all these problems. So there's a few ways you can write this. You can just put the negative right in alignment with the division bar, the fraction bar, and put the fraction 5/3. Or you can put the negative up top and put negative 5/3. Or you could put the negative on the bottom. That's less common. 5/-3 is less common. However, all 3 of those scenarios represent one negative sign. And we know from division, as long as we have one negative sign, the answer is negative. The bad idea, would be to write -5/3. That's bad. That's not the answer because that's 2 negatives and now we're back to a positive. So any of those 3 choices on the left that involve one negative sign, those are the best way to go. Okay, one last number line problem. Between what 2 whole numbers would -13/2 be found? So just like the first problem, we're going to divide to get that mixed number. I'm going to not worry about the negative right now. There's one negative in the problem, so the answer will be negative, and I'll bring that into the answer. So 2 goes into 13 6 times with 1 left over. So we have 6 1/2, and that's a negative. And so going backwards, because we're talking about negatives, we can see -6 is a little bit farther to the left. -6.5 is a little bit farther to the left than -6. So it can be found in between numbers -7 and -6. So sometimes people get tricked with the negative, so just go ahead and write off that number line, and that should help you visualize what 2 numbers it can be found in between. Okay, so now we are looking at less than or greater than negative. So in fact, 5 and 6, those are all just 2 negatives in every single problem because these are the ones to practice. And so the best bet is to write these as mixed numbers. Because if you write them as mixed numbers, then you can use that whole number part in the front to help you see what the answer is going to be. So we have -3 3/8 first. And then the second one, well, 4 goes into 15 3 times. I'll just do this one in my head. Goes in 3 times with 3 left over. And so this one's kind of close. They both have a -3. And so if you're not sure what's going on, we will just cut our line into eighths. 1, 2, 3, 4, 5, 6, 7. Oops. 5, 6, 7. Okay, there's 8 pieces. And so the -3 3/8 would be right here, because I'm counting over 1, 2, 3 pieces. And now I'll use a different color and I'm going to cut it into fourths. So those big green lines are fourths. And so 3 3/4 would be 1, 2, 3 right here. And so I can see that the 3 3/4 is farther to the left, so that will be the smaller number. So this is a greater than problem because the 3, I'll color code it. This number, the green number, was farther to the left and the red number was on the right. So the red number is bigger. It definitely gets tricky when you have negatives and you have fractions, but you can just go ahead and write out the number line and see what's going on. Okay, so now looking at B, the right side is already done for me as a mixed number, so I'm going to do the left side. 9 goes into 14. Oh my gosh, I just thought of a much better way to do this. Okay, that's fine. If you like the number line, that's fine. But sometimes with these denominators and negatives, it just gets tedious because they're so close. So this way that I like is, it's going to lead us into a good way to do addition and subtraction as well. So first off, notice I'm writing both of these as improper fractions, and I'm making sure the negative is on top. It doesn't matter where the negative is, but you need to be consistent. So either put it on top every time or bottom every time. So I'm going to put it on top. This next number, we have 8 times 1 plus 6 more, so that's 14. And so this is going to be kind of big, but I have a calculator to help me out, so that's fine. And so what I'm going to do is I'm going to multiply those two. And I'm going to multiply those two. Trust me, this is fabulous once you get the hang of it. I call this the butterfly. We are going to be I'm going to be talking about the butterfly method a lot in this chapter. And so, hey, what better time to start talking about it than now? So for these little butterfly wings, I know it doesn't look like a butterfly yet, but it will when we get to addition and subtraction. So for these little butterfly wings, we need to multiply. So negative 14 times 8 is negative 112. And so since that was this, you look at where the 14 and the 8 were, so that's going to go right on top. It has to go on top. That's important. And then the other one was negative 14 times 9, which is negative 126. And so now what we are comparing is negative 112 to negative 126. And in that scenario, negative 112 is bigger. So this fraction is bigger. Because if I wrote it in between negative 112 and negative 126, that's the way that the symbol would go. All right, let's try that again. That was a little messy. I'm going to do that same thing again with this last problem here. Okay, so I'm going to rewrite it. They're already both improper. That's fabulous. I'm just going to rewrite it so the negatives are on top. And so make my butterfly, keep that negative 16 with the negative with the 16, and then we'll multiply it by 4. And then the negative with the 11, and we'll multiply it by 6. Man, I was not very generous in the space on this chapter. Okay. Negative 11 times 6 is negative 66. So I'm going to put that right on top. And negative 16 times 4 is negative 64. So is that a less than, greater than scenario? Well, negative 64 is greater than negative 66. Therefore, negative 16 over 6 is greater than negative 11 over 4. And this becomes true. Okay, story time before we pause the video. Oh, I changed my hair. I don't even notice when I do it until I look at myself. Okay, so there's this guy, probably 75 years old, and he took my Math 80 class, and he never understood fractions like his whole life. He just hated fractions. He never understood it. And then I showed him this butterfly method, and he's like, oh my gosh, that's so fabulous. I'm going to get a tattoo of a butterfly just because, like, he wanted to get a whole fraction problem tattooed with a butterfly. And I don't know if he ever did. I'm going to pretend that he did. It makes me feel better. But that's how life-changing this butterfly method is going to be. So I know I didn't quite sell it here at the beginning. I just kind of remembered it at the last minute. But trust me, when we start adding and subtracting fractions with uncommon denominators, it's going to come in handy for some of you. You're really going to like it. All right, so I see that we are at 4.2a, so we are going to pause the video, and I'm going to go bye-bye again, and go ahead and do all of your 4.1 homework, and I will be here when you come back. And we're back. So let's look at 4.2, simplifying and multiplying fractions. So I noticed in the instructions, it's saying to reduce the fractions to the lowest terms. That's one way it's written. Or next to the number 1, it says to simplify. I'll reduce. So all of those words I put in the box mean the same thing, and you're going to see them used interchangeably throughout this section and the homework and whatnot. But the key is we always want to reduce our fractions. So looking at negative 45 over 60, we want to think what's the biggest number that goes into both of those. And sometimes, honestly, the first number you think of isn't even the biggest number, and you might have to reduce a second time. But the point is we want the situation where the numerator and the denominator have nothing in common. So I see both those numbers from the divisibility test. I know they both end in 5, so I'm just going to start with 5. So I say 14, let me have the small pen, 45 divided by 5, 60 divided by 5, and that's going to give me 9 over 12. And notice there was a negative, so I need to make sure that negative is there. Then you ask yourself, is 9 over 12, do they have anything in common? And they do. They're both divisible by 3. So I'm going to divide by 3 on the top, divide by 3 on the bottom, and I get negative 3 over 4. Now, the fact that I did it twice meant I didn't really have the biggest number the first time. And some of you might have noticed that 15 goes into 45 and 60, and that's absolutely correct. And you would have gotten to the answer one step faster than me. That's fine. Sometimes you see it, sometimes you don't. And so you just ask yourself along the way, do these two have anything in common? And once you get to the answer of no, then you know you're done. So for part B, we have 42 over 98. And what I can say for certain is that they're both even. So I will divide by 2. And I get 21 over 49. This one's positive, so I don't need to worry about that negative sign. And now that I see 21 and 49, the numbers are a little smaller, a little more manageable. And so I can see that 7 goes into both of these numbers. So I'm going to divide by 7. And I get 3 over 7, which cannot be simplified anymore. So 3 over 7 is the final answer. Again, maybe you looked at those and saw 14 right away. 14 is a little less common of times tables for people to know, but you know, people have jobs all over the place that use certain numbers all the time. So maybe that's you, maybe you saw the 14. Okay, last one. Well, 44 is 4 times 11. So let me just do a quick check. 76 divided by 4 on my calculator. And I got 19. Okay, so 4 goes into both of these numbers. Maybe I would have started at 2 if I didn't have my calculator handy. Doesn't matter, but I get 11 on the top and then 19 on the bottom. Those are both prime numbers. Nothing goes into them. So that is our final answer. Okay, so now we're going to work on multiplying fractions. And here is the rule. I'm going to write out 2 fractions, a over b times c over d equals, and what we do when we multiply fractions is we multiply across the top, a times c, and then we multiply across the bottom, b times d. Now that's a very generic way of explaining it. We will talk about how you can reduce ahead of time because I always like to make things smaller if I can. But the point is we're always going to multiply across the top and multiply across the bottom. And so for part 2, when it says only the numerators are multiplied, that is false. We multiply the numerators and the denominators across. Okay, so looking at these problems, I see on this first one, we have 4 over 7 times 3 over 13. And the rule is you can simplify any numerator with any denominator. So in example 1, we just had the only one numerator and denominator, and we talked about how to simplify those. Well, now that we have two fractions, we can actually reduce any numerator with any denominator. So checking number 3, I'm going to kind of mark this up and then I'll erase it before we start the problem. But we have 4 into 7. Nope, 4 over 7 does not reduce. 4 into 13. No, maybe if that was a 12, but since it's a 13, that's not going to work. And then I will check 3 into 13. Nope. 3 into 7. No, none of these divide evenly. So none of them have anything in common. So that really the only thing I can reduce before I get started is I notice there's 2 negatives, and 2 negatives always multiply to a positive. So I'm just going to take care of those and get them out of the way so they don't mess us up. But what's great is by doing that check early, by noticing that none of the numerators had anything in common with the denominators, I can multiply. 4 times 3 is 12. And then 7 times 13 is 91. And even though 12 over 91 is 91 is really not that common for us to just know off the top of our head, I know this answer is reduced because I checked when all the numbers were little. And I'm always all about things being smaller, checking them while the numbers are small, multiplying smaller numbers. And so since we checked them while they're small, then we know that the numbers, once they're big, it's still already reduced. Okay, so let's try this again. For part B, we have 16 over 31 and 4 over 5. And so multiplying these out, I'm going to get pretty big numbers here. So I'm going to just check it first. And I have 16 does not go into 31. 16 actually goes into 32, so it does not go into 31. 16 and 5, they have nothing in common, so that 16 is going to stay there. 4 into 31, nope. 4 into 5, no. So nothing can be reduced. We do have these two that have something in common, but that doesn't matter. You cannot reduce side to side. You can only reduce up and down, any top with any bottom. So what's left to do? Just multiply. 16 times 4 is 64. And then 31 times 5 is 155. And that's all I can do. If I couldn't reduce when they're small, then I can't reduce when they're big. And I'm hoping something in here will be able to reduce because, oh yeah, on part D, we'll be able to do some reducing first before we multiply. So that way I can show you what I'm talking about. All right, so C, these numbers are a little funky, so you might have to use your calculator to check it out. 53 and 17, but I divided 53 divided by 17, and it doesn't go in. It goes in like a 3.12 times, so that doesn't count. 23 doesn't go into 48. Yeah, I really just don't have much in common. There's no 3s that go into anything. There's no 2s that go into anything. So I shall multiply 23 times 17. And oh, before I do that, I have a negative right here. So I'm just going to put the negative in the answer. I should have done that before I even reduced, but I want to make sure to bring that over. So I have 23 times 17 is 391. And 53 times 48 is, yowza, 2,544. I definitely don't want to worry about reducing that fraction, so I'm glad we checked it while it was small because that number is too big for me to want to check. All right, last one. This will cover 2 topics, or 3 actually. This is going to talk about what we do when there's a variable, what we do when there's a whole number, and how to reduce along the way. So this will cover all of that good stuff. So first of all, when there is a variable, we don't care. We're just going to leave it alone. It's not hurting anybody. So that's not really a big deal. The bigger deal is the whole number. So when we have a whole number, that's over one whole. So this becomes 12x over 1. And it's better to write it out that way so then we can clearly see what is on the top and what's on the bottom. And then now I can reduce. Look at this. I have a 2 and a 12. 2 goes into 2 one time, 2 goes into 12 6 times. And so now that's all I can do because I only have ones left over on the bottom. Now when I multiply, I have 15 times 6x, which is 90x. And then I just have ones on the bottom. So technically I have 90x over 1, but it says to simplify it, we don't write it over 1. We just write the whole number, 90x. And so if I had done it just first, I would have 15 times 12, which is 180, over 2 times 1. And in this particular problem, that wouldn't have been too terrible to reduce because you know the top is even since it ends in a 0. However, it's just always nicer to have the small numbers. So this also reduces to 90x. But now we don't have to worry about it because we reduced it first. All right, so I'll take a quick and come back with 4.2b. And we're back. And so 4.2b, reciprocals and dividing fractions. So the reciprocal is what happens when you flip the fraction over. And the reason it is important is because when you multiply a fraction by its reciprocal, you always get 1. So let me just flip this over first, and then I'll explain that second part. So you literally just write the bottom on the top and the top on the bottom. That's the reciprocal of 12 over 5. And off to the side here, you can see 12 over 5 times 5 over 12. The 12 goes into 12 one time. And then those are both 5s. They go into each other one time. So the answer is 1. So that's why we use a reciprocal. It will cancel everything out and we'll be left with a 1. It's the same idea as adding the opposite to get a 0 pair, like -2 plus +2 equals 0. It's that same idea. Okay, so you need to keep the sign. In this case, we have a negative. So this is going to be a negative 11 over 3. Because that way, when you multiply them together, the two negatives cancel out and it will still equal a positive 1. So the reciprocal of a positive number is a positive number. The reciprocal of a negative number is a negative number. Reciprocal does not mean opposite, it means flip. So we are going to flip the same fraction. All right, last one, flip it, 13 over 42. All right, but I said opposite, and we do see opposite here because opposites are what we add to get 0. Reciprocals are what we multiply to get 1. They both have very important roles in equations. And so just to make sure we get the idea of it all, the opposite of this number is a positive. The reciprocal of this number is a negative, and we flip it over. I'm going to do the middle column in a second. The opposite of the second number is a negative. The reciprocal of the second number is a positive, just flipped over. So opposite means plus or minus. And reciprocal means, I guess that means flip that picture. Reciprocal means flip. I was just trying to draw a picture of it. All right, absolute value means distance away from 0, which is always positive. So negative 33/15 is 33/15 away from 0. It's a positive number. 2/9 is 2/9 away from 0. It's a positive number. So remember, absolute value doesn't mean anything about positive or negative. I mean, doesn't mean anything about opposite. It means the answer is always going to be positive. Okay, so why do we need the reciprocals? Well, we will need it when solving equations pretty soon, but we are also going to need it here when we are dividing fractions. So we have 12 over 7 divided by 3/5. I told you a little bit earlier, I try to make a lot of mnemonics around food. which is ironic because half of the places I talk about I don't even like, but the commercials are catchy and it helps me remember. So to divide two fractions, I always think of KFC. And so what KFC means is we're going to keep the first fraction, we are going to flip the second fraction, and then we are going to change to multiplication. Keep, flip, change. And by saying it in KFC, we know since the K comes first, we're going to keep the first one. And since the F comes second, we're going to flip the second one. And really what's happening is to divide, we don't have any rules for dividing fractions. So what we're going to do is multiply by the reciprocal. And so we can do that by taking 12 over 7, flipping and getting 5 over 3, and then changing it to multiplication. And so I am going to work these problems out in just a second, but I want to practice that KFC a few times. So we're going to keep the first fraction. We're going to flip the second fraction, and we're going to change to multiplication. Notice I brought that negative over. It doesn't matter if the negative is on top, on bottom, out front, as long as the negative's there somewhere. And then finally, keep the first fraction. Oops, that's a 6 on the bottom. Flip the second fraction and change to multiplication. Okay, now that we have multiplication, now we can talk about reduction. You cannot reduce unless you're multiplying. So I need to, you know, that's actually a really big rule. It's going to come up over and over again throughout math. So I'm just going to write it here. You cannot reduce unless you are multiplying. Exclamation point. That's how exciting it is. Okay, so typically people try to reduce when it's plus and minus, and that's why this rule is such a big deal. But people also try to reduce when there's division. So now that we've made it to multiplication, now we can reduce. We can say 3 goes into 3 one time, 3 goes into 12 4 times. And now that I have that multiplied or that reduced before I multiply, I can multiply 4 times 5 and get 20, 7 times 1 and get 7. And so I have that as my final answer. It's already reduced because I reduced it before I multiplied it. Next up, whenever I'm reducing, I do like to circle that negative because sometimes when I cross things out, the negative accidentally gets buried. So 9 goes into 9 one time, 9 goes into 18 2 times, and neither 2 nor 4 go into 35. So I am done reducing, and we get 35 times negative 1, which is a negative 35, and then 2 times 4 is 8. And that is our final answer for part B. You don't need to write these as mixed numbers. These are perfectly fine as improper fractions. And just make sure you have one negative sign somewhere in that problem for part B. For part C, I noticed the 21 and 6. Well, let me take care of the negatives first so I don't lose them. So I have 2 negatives, so those are going to become positives. Multiplying 2 negatives becomes positive. 21 and 6 have a 3 in common. 31 does not have anything in common with either denominator. 7 does not have anything else in common with either denominator. So I am done reducing, and I get 7 times 31 on the top, which is 217. Remember, this is positive because I canceled out both of those negatives. And then 2 times 8 is 16. So I get that as my final answer, 217 divided by 16. Okay, so that is the end of this section. So rather than put up a pause the slide video, I'm just gonna stop this video so they don't get too long. Last time they were a little too long. I like breaking them up a little better. So this way they don't get too long. And also you have time to go do your 4-2 homework before you click on the next video. All right, so I will see you in the next one.